In this example, we're going to sketch the graph of f of x equals log base 1/2 x and then give the domain and range. So step one is to identify the base. So we see here our base, log base 1/2 of x. Our base is 1/2. And recall when the base is a number between 0 and 1, that it is going to be a function that is going to be decreasing, meaning from left to right is going to be moving in a downward motion. The other property of a log graph is that it will have the following points on its graph. So if the base is 1/2, so you'll have 1 over 1/2, which equals 2, negative 1, and then you'll also have the other point 1, 0. If b is 1/2, then you'll have the point of 1/2, 1. Okay, so again, your new points would be 2, negative 1, 1, 0, and 1/2, 1. We also know that the graph of a log function will have a vertical asymptote at x equals 0. And so we can go ahead and sketch our graph, and it's going to look like so. Next, we want to identify our range. Let's start with the domain rather. The domain, recall, is going to be from 0 all the way to positive infinity. Range, you have arrows on both ends, so it's going to go forever up and down. So the range would be from negative infinity to positive infinity. And there you have it. Graphing or sketching the graph of a log function by using its properties. Now we're going to graph this function by finding order pair solutions. So I'm going to go ahead and pick a few points for x. I'm going to use 0, 1, 2, and 4. So let's start first by plugging in 0 in x's place. So when I rewrite it in exponential form, I'm going to have 1/2 raised to the x power equals 0. So I have to think of, okay, what do I have to raise 1/2 to in order to get 0? Well, there is no number that I can raise 1/2 to and get an output of a 0. So that would be undefined. That point is not on the graph. Let's move on to the next point. Plugging in a 1 in x's place, I'm going to have 1/2 raised to the y power equals 1. So we want to know what number would I have to raise 1/2 to in order to get 1. Well, I can think of 0. Remember, any number raised to the 0 power equals 1. So our y output is 0, so our ordered pair would be 1, 0. And that's right in line with the properties of a logarithm, which means that we will have that point at the one of our x-intercepts would be 1, 0. Moving on to the next one, if you plug in a 2 for x, we'll have 1/2 raised to the x power equals 2. And so I want to know what number that when I raise 1/2 to that power, I'm looking for a number that would give me 2 when I raise 1/2 to that power. So what do you think it is? Well, let's think about it. My fraction is 1/2. If I flip 1/2, it becomes 2 over 1, which is the same thing as 2. And so to flip something that already has a positive exponent, the exponent would then be a negative. So your answer would be -1, because 1/2 raised to the -1, when I flip it, it will become 2. So my order pair is 2, -1. We have one more. Let's plug in a 4 for x. That will be 1/2 raised to the y power equals 4. So I want to know what number will I have to raise 1/2 to in order to get 4. And that would be, again, where I would have to flip this, because if I flip 1/2 and I get 2, and once you get 2, you say, how would I get 4? Well, if you square 2, you would get 4. So therefore the answer would be -2 because you have to flip it, and in addition to it you got to square it. So y would be -2. My ordered pair would be 4, -2. And now that we have all our points, all we need to do now is go ahead and sketch our vertical asymptote, which is going to be x equals 0, crossing the x-axis right at 0. And we go ahead and sketch our points. And there you have it, the graph of f of x equals log base 1/2 x by plotting ordered pair solutions.